Let's do it. All right, so again, this is straight from the book, and I'm going to remind you guys, if there is ever a section you want to see other examples or do other examples, it does go with the online book, and the book has the examples worked out. So like if you're doing one of the homeworks and there's a type of problem that you're just like, I'm not sure about this, go to that section in the book and you can see in the homework and like click worked out examples and be like, how did they do it if you need our example. Sound good? Because again, most of the stuff is coming directly from that online book. There's a few things that we're going to do that aren't, but most of it's going to be. All right, so we're going to talk about lines, linear equations, the whole shebang. So if any of you go on and you end up doing calculus, you're going to find that this is actually pretty much what you're dealing with most of the time. You're finding the slope at a point and a line that passes through it. So some quick reminders. Slope-intercept form is y equals mx plus b, right? Where m is your slope and b is your y-intercept, which we talked about how to find yesterday. All right. What is slope? Is it something you go skiing on? Like I just went on a ski vacation. It started off great, but it was downhill from there. Ooh. You can boo that. You can boo that. That's a. So you guys have learned, you know. Oh, it's gonna be a long year if the screen keeps doing this. Someone's got the remote. Someone doesn't want you guys to learn college algebra. Yeah, one of my subscribers is hacking the system. It's anonymous. All right, I'm gonna grab my mouse to move it periodically. All right. So slope is delta y over delta x. You guys know what that delta means? That's actually the reason why they call it. Oh, I can't talk about them. They're a rival school now. But delta means change, right? So change in y over change in x. You guys would call it rise over run. You could do it as, ooh, someone asked this on the first day, why would you ever use an x2 and an x1? There, for slope, right? Because you have two x's and two y's. It's also a rate of change. If you're driving and you're going a speed, that speed is a slope. It's miles per hour, right? So speed, acceleration is all slope. Slope is a lot. Technically, if you go to the store and bread's like $2, that's a slope. It's $2 per item. It's a rate. Okay, so keep that in the back of your head because on Monday we're doing nothing but story problems. All right, slope. Oh, I wrote the slope formula already, but we'll write it again because we're going to use it quite a bit. It's a slippery slope. All right. Cover your ears, internet people. The standard form of the line is one of the most pointless things taught in mathematics. Don't know why it's such a big deal. But it's ax plus by equals c. A, b, and c are all integers. You can't use fractions when you do it. I'm pretty sure I don't ask you any questions about like converting something to the standard form. The equation of a line I find more important is actually going to be point slope. And that's your y minus y1 slope times x minus x1. Because if I'm given a point and a slope, I can just plug it in, right? And that's usually what we're given. You're given a point and a slope. Very rarely you're like, here's an intercept and a slope. Find the equation. Usually given this. So if you guys want to make a little key up here, I gave you slope and y-intercept. x1, y1 is what? That's a point on the line. x2, y2. is a point on a line. Sound good? Anything too scary? Move my mouse and screen. It's my eraser. Again, don't have my coffee this morning. All right. Let's do that's I think are nothing but examples the rest of the way. And I made sure all these examples, oh, not that one. I didn't give you any like that. All right. So let's get to it. Find the slope. We might do 1 or 2 story problems today. So the biggest thing with slope is remembering it's y over x. It's rise over run. That's still the biggest mistake I see made at every level. Even when I used to teach AP Calc, #1 problem I saw was people would flip their x and their y's. Okay? So we're going to be using slope formula to find slope. Okay? Now, if you get really stuck, you could graph and just count your rise over run, right? Will that work? Every time. That'll work every time. Because remember, slope is the actual physical thing. So I'm going to take my points and I'll label them. X1, Y1, X2, Y2. And now I just have to plug them in. So Y2 is 3 minus Y1 is -1. And then we got our -5 minus 2. Simplify this beast. Bad thing happens to a bad person, that's a good thing. And these are both negative, so I'm going to keep my signs. And I'm going to, that's good. Fractions are good. What's a negative slope look like? Just a reminder. Like if I'm graphing something that's negative, what's happening to your Bitcoin? It's going down, right? If it's fractional, it means it's going down slowly. So I just want you to start visualizing that, because then when we get to more graphing, it's going to be easier for you to look at a graph and say, did I do this right? It makes sense. So it's going to be a gradual, slow Mr. Twilliger's bank account over time. All right. Oh, look, that one's already labeled. All right, next one. Find the slope of the line that passes through those points. All right, boom. Label them. Same thing. Y2 is 4 minus my Y1 is 6 over my X2 is 1 minus my 1. I always put my negative ones in parentheses just to remind me that there's 2 negatives there. 4 minus 6 is -2. Comes a positive 3. Another -1. Yep. Questions, comments, and or concerns? All right. All right. Usually I want to, we'll hold off on that. All right, let's just keep trucking then. All right. Given an equation, this is one of the ones from your homework set. All right. There's a question just like this on the homework set. Don't overthink it. Find the slope and the y-intercept of this beast. So I go back in time and I think about the equations. Y equals mx plus b, where m is my slope and b is my y-intercept. So when I look at this equation, I have it all, right? I have my m, I have my b. That's it. Pretty much done. So my slope is -3/4. my y-intercept, -4. We good? All right. Guided notes for the win today. All right. Here's the point slope formula once more. I had you guys write it above. Now we see it again. Again, this is going to be the one I go to probably the most. Formula you're going to use the most. Because you can do stuff like this. All right, you guys can. So, given you have a line with slope of 3, -3, and you have the point 48. Write the equation of the line in slope-intercept form. So now, we're not going to finish by writing it in point slope form. We need to always go back to y equals mx plus b because intercept means a lot and the slope means a lot. Ooh. Challenge question. Ticket question. In y equals mx plus b, we know m is my rate of change, right? It's my slope, miles per hour, how much things cost, how much a Barbie doll falls given another rubber band. You'll learn that if you take stats. What's my y-intercept actually mean in real life? What would my y-intercept mean in real life? If slope's the rate of change, why do I care about the y-intercept? Starting cost, starting speed, starting distance. There you go. So y is where you start, or you would, if you take stats, the term you use is when x is 0, that gives you what your value of the equation is, all right? So think about your intercept. That's your starting amount. That's your starting distance. That's your starting initial value. All right, I digress. So we're using our formula, right? And now I got to go and find what I have. I have a slope, and I have an x1, y1. If you are ever given a formula, oh, hold on, I won't say it. Don't speak in absolutes. That's actually good relationship advice, too. Never speak in absolutes. Do you guys know what I mean by that? Don't tell someone they never do something or they always do something. That's a dangerous, dangerous game to play. That's free advice for the internet, people. All right. So now I'm just going to plug in and solve. Y minus, my y1 was 8. Watch your signs on this. My m is -3. X stays x because it doesn't have a value to plug in. Minus my x1, which was 4. All right. Now again, that is a great equation. We put it into y equals mx plus b because slope and y-intercept are the two most important things we need from an equation, right? So we need to convert this back to a slope-intercept form. Also, you have a homework question that has it written out longer and more, and they ask what's the slope and y-intercept. You have to get into that y equals mx plus b form to find the y-intercept. Or I guess you could graph it and see, but it's going to be easier just putting slope-intercept. So simplify. So I'm distribute. Because honestly, converting, it's always going to be 2 steps, pretty much distribute, subtract. We'll add in this case. Add my 8 over. Get y equals -3x plus 20. So now I know my y-intercept's 20. My slope is -3. Okay. Now, if you had graph paper and you need to find a y-intercept, could you also graph this given the slope and the point? You could. That works as well. There's more than one way to do most of these problems. All right. Here's what I want you guys to do now that we're there. I want y'all to try this problem. Try this one, number 8. If you're in the video world, go ahead, pause, and try it. Give it a try yourself, and then I'll go over it. All right. Sorry for those of you on the online world. So m is 4. And the point you're looking at is 2, 5. So your slope is 4, and the point is 2, 5. All right, hopefully you gave it a shot. Let's see how we did. So my slope was 4. Was it 2, 5 was my point? All right, so then my x was 2, my y was 5. Now again, I want it in slope-intercept form, so I need to distribute that 4 through. And add my 5. It's pretty much the same steps every single time. How do you guys do? All right. Bless you. I should mic up one random student per class without telling him.
You should mic me up.
No. Absolutely not. So, here we go, vertical and horizontal lines. Again, this, honestly, sometimes with this, there's so few steps, you feel like there's no way you can mess up, but then these are going to be the ones people are already doing the homework are making mistakes on this one with which ones are vertical and which ones are horizontal. So, equation of a vertical line. So, let's talk about for a second. If I have a vertical line, right, here's my vertical line, and let's say it's at 3. If I pick a random point on this line, that one right there, what point is that? That's 3, 0, right? What's this point right here? Let's say that's 3, 3, 3. What would this point be down here? 3, negative something. No matter what point I pick on that vertical line, what's going to stay the same? The 3, which is my x. So the equation is x equals something, right? So a vertical line is x equals because no matter where I pick a point, what can y be? I don't have y in the equation because y can be anything it wants to be. It could be e, or I, or OU. No, it could be negative 6,000. It could be anything. It could be 6, 8. All right. So now what's the slope of this? Let's talk about why it is. Okay, that's what. How far do I go up before I go over? I go up infinite over. How far am I going left or right? That's I go up infinite. How far do I go over? 0. Can I divide by 0? Absolutely not. So that's why that one's undefined. The big mistake made with this is people say it doesn't have a slope. Does that have a slope? Yeah, it exists. But can I define it with a number? No. So it has a slope. The slope is undefined. Okay? So vertical is x equals something. And in reverse, if I give you a horizontal line like this and put it at 2, every point is going to be like 1, 2, 4, 2, negative 5, 2, right? What's going to stay the same for every point on that horizontal line? The y, yeah. So it's always going to be y equals something. Okay? I don't know. Nah, be careful. All right. So y equals question mark. So what's the slope of this beast? How far do I go over? Well, you don't start with, how far do I go up and down? 0. 0, right? Rise over run. How far do I go over? Infinite. Now, can I divide 0 by a number? How many what's division mean? This is what I want. What's division actually mean? If I have 10 pieces of candy and 5 friends, how many does each person get? 2, because it's 5. How many are in 5 groups of 10? Or if I have 10, making 5 groups, how many in each group? If I have 0 things and I make 10 groups of 0, or 10 groups, how many are in each group? 0. So you can divide anything by, or 0 divides in anything. All right, you guys love it. All right, 0. So we have our 0 slope, undefined slope. The biggest thing that's going to happen is mixing up your x and your y. So I don't know. It does help to graph it and sketch it and think about the points on that line. Like what's staying the same, what's changing. All right. Did I skip these top ones? All right, that's fine. That's good. I actually like this part. So let's go back up. We're going to go reverse. I usually like to start with that. All right. That was a good spiel. Let's go back in time. What if I'm given 2 points and need to find the equation of a line? Can I go right slope intercept form if I'm not given an intercept? No. So I'm going to always start with, I shouldn't say always, but majority of the time you're going to start with this equation. Now, what 2 things do I need to do that? I need a slope and a point. Do I have a point? I do. Which point should I use? Doesn't matter. Doesn't matter. When I go to plug it into here, I can use either point. I'm going to tell you which point I would probably use. I'm probably going to end up using that one with a 0 because then I don't have to calculate with it, right? It's going to go away. We'll get there when we get there. What do I need to find first? I need to find my slope. Okay? Got to find that slope. All right. So let's start plugging in stuff. So my x1, y1. Now, if you ever mixed up your x2, like if you made that x1, y1 and that x2, y2, it will make 0 difference in the end of the problem, right? As long as you're consistent. Consistency is key. The great philosopher Troy Shelkey said that. All right. So we have -3, my y2, minus 4 over 0 minus 3. Any questions for any of that? It's just our slope from before. So I get -7 over -3. What's a negative over a negative become? Yeah, it becomes positive. I was just making sure I had all my signs right. I haven't looked at my notes once yet, so I'm hoping I'm doing these right. Comment in the video. All right, so that's my slope. Don't leave me alone. All right. So now when I go to plug in my point, I'm going to plug in the x1, y1 because I labeled it that, and I'm going to be consistent. If this was real life, I would have plugged in that point just because then I would have to deal with the 0. But I'm going to use the one I label as x1, y1. I can use either point. Some people say, what's the point? All right. So now I'm going to distribute fractions. We're going to get in a fraction world. It's okay. Just be nice to them and they'll be nice to you. So that becomes 7/3 x minus 3 times 7/3. What's really nice about that is what happens when I multiply something with the same denominator. They can cancel, right? What's 3 divided by 3? 1. I'm just going to rewrite it so it's a little bit cleaner, kind of. Add my 4. I get y equals 7/3 x minus 3. So really, we did the same thing we did before. We just had to find the slope first. We just combined the 2 things we did earlier, right? We did slope. We did that. I'm not going to make you write an equation in standard form because I don't want to. All right, we're good. All right, my equation line passes through 2 given points. All right, we're going to do the same thing again. So what I want you to do, if you're in the video world, go ahead and pause this and try this. If you're in here, go ahead and give this one a try. It's just like what we just did. Given 2 points, this is example 13, find the equation line in slope-intercept. All right, how many of you guys found the slope and then got a little bit confused and tried to plug it in and it was wild? Here's my advice for you. This is, in this equation, do my x's change? So what's that mean about my x's? What are they always going to be? 1. So x equals 1. Because if you graph it, you're going to get a vertical line at 1. So I'm sorry, guys, I kind of tricked you. So when you went and found slope, which you should still do, when you went and found slope, you would have done 4 minus -3, and you're feeling good about yourself. And you went 1 minus 1. It's like, good, I can do this. And you got 7 on top. Yes. You went 0, and you're like, oh, no. Remember, 7 over 0, can I divide by 0? No, that's undefined. If it's undefined, that's a vertical line, okay? The other thing, this is also what I want you guys to get used to. Don't just get stuck in the trap of trying to follow the same steps every time. If you looked at this problem, you could have looked right away and said, my x's didn't change. So if I were to graph that, it's going to be a vertical line. Or if you look in your y's are the same number, guess what? It's going to be a horizontal line. You don't need to do any calculations. The answer, this, yep, x equals 1. The slope is undefined, so it's x equals 1. So if you have slope is 0, it's always going to be a y equals, right? Slope is 0. Now what I want you to do is this one. All right, I'll be nicer. This one actually works. Go ahead and try this number 10. I can walk around and help you out. Sorry, people in the video as well. Go ahead and pause it, try it, and then we'll go over it. All right. I did it again. What's my y values? But now again, if I'm chugging along problems and finding the slope every time, this is how I would find my slope, right? So say, oh no, it was 0 over 7. But if my slope's 0, it's automatically going to be a horizontal line, right? Now what's nice about these, actually, if you went through and did the whole problem, so then I do my y minus 2 equals 0, x minus -5, right? Like if I plug it in, I'm going to get the same answer on these, right? Because I'd get y minus 2 equals 0, y equals 2. So this is one where you would still get the right answer if you did all the steps, okay? All right, I'm sorry. I'm not, though. All right, parallel and perpendicular. All right. If 2 lines are parallel, the slope is equal, right? I don't know why that y-intercept's there, because the y-intercept doesn't matter. It doesn't matter if they're parallel or not. So remember, parallel lines look like this. They go on forever and don't touch. So the m, this is not how the book does this, how I do it. M1 equals M2, right? The slope of the one line equals the slope of the other. I guess I'll do this. The y-intercept does have to be different. I will add that in. Because what happens if their slope is the same and the y-intercept is the same? They are the same line. So technically, if they have the same, they wouldn't be parallel. You're just graphing the same line on top of each other. So that has to be different. Perpendicular, you guys, here's your new term for the day, orthogonal. Orthogonal lines mean that they are perpendicular to each other. You won't we won't do anything with that. If you go onwards and upwards, orthogonal is a big deal. Vectors. The slope is apo-reciprocal. So the slope of 1 is equal to 1 over the slope of 2 negative style. You flip it and negate it. You have to do two things to it. Okay? The y-intercept doesn't matter. Y-intercept doesn't matter, right? Because if they're opposite reciprocal slopes, they're going to hit at a right angle somewhere on the graph. Doesn't matter what they are. They cannot be the same line. They will only cross once. What just happened? Oh, it went back. I can do this. I've used a computer before. All right. Good talk. All right, let's do this. I have two equations of a line. I need to tell whether they're parallel, perpendicular, or neither. Okay? So I'm going to take both. You need to convert both your lines into slope-intercept, and then you can compare slopes. That's what you do. Oh, and intercepts, because if the intercepts are the same and the slope is the same, that would actually be a neither. They're the same line. So for this one, to get y by itself, I'm going to divide everything by 3. So get y equals negative 4 over 3x plus 1, right? So that's one of the lines. Now, if you're taking like a standardized test of some sort and you can use Desmos, you can plug these equations in directly and then look at them. That is actually a strategy that works. You don't need to have it y equals on Desmos. You can plug them both. But here, we're getting you to do the y equals. Just a hint for anyone who is interested. So I need to get y by itself. I'm going to move over that x. Then I'm going to divide by my negative 4. Divide everything by negative 4. Negative divided by negative is a positive. Minus 2. Up here? Oh, sorry, that was a whole different side. So I went through and I divided both sides because there's a 3 in front of that y on the left one. Two different equations. Example 14. All right, so now compare our slopes. How do 3/4 and negative 4/3 combine? They're not parallel. They're not the same. Are they opposite reciprocals of each other, though? One slip. So it's flipped and negated. So there's two things that happen to it, same numbers. So that's perpendicular. So when I compared my two slopes, I got 3/4 and negative 4/3. They're opposite reciprocal. They're flipped and negated. The test, there's actually a rule to prove they are. You multiply the slopes, and if it's negative 1. That's actually a rule. If you multiply the slopes, that's something, again, that's in pre-calc with vectors. A lot of this stuff, honestly, pre-calc and calc are pretty much algebra 3 and 4. It's just a lot of this stuff. But there's meaning behind it. Like, why are we doing this? Like, why is that important? So when I multiply those, you get negative 12 over 12, negative 1. So that's how you'd prove they're perpendicular. If the slopes multiply to be negative 1, they are perpendicular. You don't have to do it that way. All right. All right. You guys try it. Pause the video. You guys try this one. There's no undefined slopes on this one. No zero slopes on this one. I promise. Get y by itself though. At least try. So again, if you're in the online world, you can look at it's 2y minus x equals 10. And 2y equals x plus 4. Wunderbar. All right, first step, I gotta get that y by itself, right? Luckily on this one, all I have to do is divide by 2. Okay? I get y equals x over 2 plus 2, right? Or 1/2 x. Both are fine to write, right? However you want. I'll put the 1 in front for funsies. Now to get y by itself, I'm going to add x. Add x. Get 2y equals x plus 10. Divide by 2. So I get 1/2 x plus 5. So different y-intercepts, so they are not the same line. What's true about these two slopes? 1/2 equals 1/2, so they are parallels. Like if they're the same line, yeah, neither. Same line. Very rare occurrence. But yeah, you'd say they're the same line. Because technically, parallel means they never cross. They would cross at infinite points. They cross everywhere they could. All right, here we go. We're going to do it. Now, what do I do if I want to find the equation of a line that's perpendicular or parallel to a line given a point? I'm going to zoom out a little bit so I can actually see this all for the people. All right. What have we done almost every problem? First thing we've done? Find the slope. Okay. Easiest way to do it is going to be to get in slope-intercept form. We're going to use that slope and the point to do point-slope form, just like what we did, but we're just building on what we've been doing. And then we're going to simplify it and compare. Okay. Okay. Let's do it. All right, given the equation 5x plus 3 equals 5x plus 3y equals 1, and we have a point that we need it to pass through that's 3, 5, give me the equation of the line. So first things first, well, I'm going to put this in the back of my mind. I'm going to be using this formula, right, to write the equation of the new line I'm finding. I have a point. So I have my x1, y1. So that part is good. That's done. What am I missing from this equation? Actually, I can even just start filling out. I'm going to do y minus 5 equals slope times x minus 3. Okay? Right? I have that. That's given to me. So I need to find the m. This will have it somewhere in there. But what I need to do to it is get it all by itself. Get that y by itself. Here's an old reference. As the offspring once said, you have to keep them separated. Anyone born in the 90s? No? Okay. I'm going to rewrite this just for better order. Step 1 minus 5x. All right. Now I'm going to divide everything by 3. Now what's nice about this, do I care about the y-intercept on this one today? No, because I'm harvesting the slope from it, right? I'm finding that slope from it. What is your slope? I mean, I'll write it for funsies, but that doesn't matter on this one at all. That's all I care about. So my slope is negative 5/3. Now, before I get too crazy, I'm going to go back and look. Were they asking for perpendicular or parallel? Okay. Parallel. So if it's parallel, I don't have to do anything, right? The slope is what the slope does, what the slope do. I'm just going to plug it in. Now, if you take calculus, most of the time you can leave it like that. All right, but we're not there yet. So we're going to make this into a form that we have a slope and an intercept. So I'm going to distribute. Oh, what's going to have my 3's on these when they multiply? They're going to cancel, right? Because what's 3 divided by 3? 1. Oh, buddy, this is going to be wild. I'm going to add a 5. I'm going to get negative 5/3 x plus 10. Okay. All right. That was a lot. I know, right? We're almost out of here. Perfect. How much time I got? Oh, I'm going to finish this. If the bell rings, that's fine. If you need to leave, you can leave. I'm going to do this one problem because then we're good for the day and I need it on the video. Sound good? All right. Same thing. Find the equation line perpendicular to that piece through the point. I'm going to do my y minus y1 equals slope times x minus x1. So I'm going to plug in my points. Just a reminder too, make sure first 2 homeworks could be done and you can do the first 6 problems of the 3rd homework set after today. All right, you can do the first 6. All are. If I didn't start them? You should start them. All right. So I'm going to do y minus 1 equals slope times x minus negative 4. Right? Make that a plus. Now, I need to harvest my slope from this beast. So I need to get y by itself. So for this one, I'm going to move over that 4, and I'm going to move over that 5x. Remember, you can do that. It'll save you a lot of time. You could do it step by step as well if you need to. That's fine. And then I'm going to divide everything by negative 3. Okay? So y equals, that becomes a positive 5/3 x. Don't care about the intercept. I'm just harvesting slopes right now. Now, can I just take that slope and convert it over? No. It's perpendicular, so what do I do with it? Flip it and put a negative in front. All right? Flip it and put a negative in front. Sound good? And then from there, take that, turn it to slope intercept. Sound good? And there you go. I finished it. You can see in the lower left hand if you want to check yourself. Thank you and have a great day.